आज हम एक्सरसाइज में शॉर्ट क्वेश्चंस जो है वो करते हैं। तो शॉर्ट क्वेश्चंस में फर्स्ट क्वेश्चन है, क्रिएट द टेबल टू शो रीजनेबल एस्टिमेट ऑफ सम फिजिकल क्वांटिटीज। तो ये बुक के अंदर गिवन है, उसमें आप उसको थोड़ा सा हम देख सकते हैं। इसमें लिस्ट ऑफ सम फिजिकल क्वांटिटीज और एस्टिमेटेड वैल्यूज of some quantities, length, mass and time. Diameter of atom is of the order of 10 per minus 14 and diameter of nucleus is of the order of 10 per, this is 10 per minus 10 and this is 10 per minus 14. Then it means nucleus is smaller than atoms and approximately 10 power 4 time that is smaller. Now we can talk about diameter of proton. There are number of proton in the nucleus. It means proton is smaller than nucleus as well, and approximately that is of the order of 10 power minus 15. And this is a diameter of and another diameter of the big diameter of electron. Electron is again these small particles, therefore this is also thousands time minus 18 of the order of 10 per minus 18 meters approximately. Some big quantities, diameter of Earth is of the order of 10 per 6 and diameter of moon smaller than that of Earth. This is of the order of 10 per minus 4, etc. Mass of atom is of the order of the order of 10 per minus 27 kg 26, and mass of the nucleus is also approximately 10 per minus 26 kg, because mass of atom and the nucleus is approximately equal. Mass of proton is of the order of 10 per minus 27 kg and mass of electron is 10 per minus 31 kg and mass of Earth 10 per mass of Earth is 10 per 25 kg and mass of the moon is 10 per 22 kg. This is approximation. Now we take the mean lifetime of unstable time period of visible light of the order of 10 per minus 15 seconds. Time period of nerve impulse -3. Time for one heartbeat approximately 1 second and time of 1 day 10 per in seconds, that is seconds, and age of earth is approximately 10 per 17 years. Age of universe. Now we take next question. Question number 2. Express the unit of the following derived quantities in base units. We have to convert the units of derived quantities in terms of base units. For example, force unit is Newton. So since F is equal to ma, so Newton is equal to kilogram meter per second square, kilogram meter second inverse square. So Newton is the derived unit, and kilogram, mass and second, these are the base units, are fundamental units. So force, the base unit of the force is kilogram, meter and second. So the base units of force, kilogram, meter and second, with this ratio. Another quantity is work. Work is the multiple of force and displacement. Derived unit joule, and this can be written as Newton into meters. Force in newtons, displacement in meters, and the Newton we have just derived the kilogram meter second inverse into meter, so we get kilogram meter square second. So the base units of work and energy also. This is the answer for the base units. Another quantity is power. Power is defined as rate of doing work, and this is work over time. Derived unit of power is watt. Since watt can be written as joules over time in seconds, joules Newton into meter over seconds, Newton is kilogram meter inverse square into meter over second. So this is kilogram meter square second inverse cube. So this is the base unit of power. Kilogram mean mass, meter square length and second inverse cube. So this is the base unit of power. And then base unit of pressure. Pressure is force acting on unit area. Force over area, and we define it force acting on unit area. So the derived unit is Pascal, which is also equal to Newton per meter square. So that Newton per meter square can be converted. This is kilogram meter second inverse square Newton and into meter inverse square. So we get kilogram meter 1 minus 2 second minus 2, and we get kilogram and So this is the base unit of pressure. Another quantity is electric charge. Derived unit coulomb, and V symbolically that is written as C. Since I is equal to Q by T, Q is equal to IT, so base unit of charge ampere into second. So these are the different base units of different quantities. Now we discuss question number 3. What is the importance to use the instrument of small resolution mean small least count? We know that smaller the least count of given instrument, precise will be the measurements made by that instrument. That's why we prefer the instrument having small value of least count, resolution of the instrument to get better result. Question number 4. What is the importance of increasing the number of readings in an experiment? What is the importance of increasing the number of readings in an experiment? This is very important to take the number of readings. Number 1, experimenter become confident if he perform greater number of readings. Number 2, we calculate the average or mean value of greater number of readings. That will be more reliable error in the performance will be least. Question number 5. What is the difference between the precision and accuracy? Precision mean closeness in the measurements taken by a instrument while accuracy mean closeness in the mean value of the measurement with the standard value of that quantity. For example, measures the value of G by simple pendulum 9.5, 9.51, 9.49, 9.52. These are precise but not accurate, and if another student measures the value of G equal to 9.80, 9.81, 9.79, these are accurate. Question number 6. Principle of homogeneity. It is the principle in which we prove that both sides of an equation have same dimension. For example, S is equal to Vt, the dimension of left hand side is dimension of right hand side, dimension of V is in dimension of time, so dimension of Vt is m0 L t minus 1 into m0 L0 t, then this is m0 plus 0 L1 plus 0 t minus 1 plus 1, and this is equal to m0 L1 t0. Now dimension of both the sides. Dimension of left hand side and right hand side It means this equation is dimensionally correct, and this is what we call principle of homogeneity. So question number 7. A ball is thrown in air by 5 different students are individually measuring the time it takes to fall down using the stopwatch. The times obtained by each student are time measured by different student. This is 6.2 seconds, 6.0 seconds, 6.4, 6.1, 5.8. What is the uncertainty of the result, and how should the resulting time be expressed? First of all, mean, we take the mean value of time. So T average is 6.2, 6.0, 6.4, 6.1, 5.8 divided by 5. ये 30 है आज, तो जवाब आया 6.1 seconds. This is the mean time we have calculated. Now the difference of each quantities with the mean values. Now the difference in each quantity. Delta T1 is 0.1 second. Delta T2 is again 0.1 second. Delta T3 is 0.3 seconds. Delta T4 is 0, and delta T5 is 6.1 minus 5.8, 0.3 seconds. ये 0.1 plus 0.1 plus 0.3 plus 0.3 divided by 5, 0.8 divided by 5, 0.16 है, ठीक हो गया. So the mean value, this is delta T mean जो है, this is 0.16 seconds. So we can write this the quantities. So result is T plus minus delta T is equal to 6.1 plus minus 0.16 seconds. So this is the way we have determined the uncertainties, mean, and then we write the formula, write the result in this form. T plus delta T is equal to 16.1, 6.1, not 16, this is 6.1, and plus minus 0.16. Last question. Energy of the photon is given by the equation E is equal to, question number 8, E is equal to HF. H is the Planck's constant. Find the dimension of H. We have to find the dimension of H, Planck's constant. Since H is equal to E by F, E is the energy, F is the frequency. Units joules and second inverse. Joule is Newton into meter over second inverse. This is equal to kilogram meter base unit of Newton into meter over second. This is equal to kilogram meter square minus 2 plus 1, and this is kilogram meter square second minus 1. These are the base units. So the dimension of H, Planck's constant, is mass, length, T minus 1. So this is the dimension of Planck's constant.